Now we are going to discuss about the seismic waves, which is the basics of seismology. So let us discuss about seismic wave. Before I want to discuss about basics of some waves, that is major category belongs to the two types of waves. See, now I run this video for your benefit. Just see this video and then you can come to the conclusion. See, all of you might have know about the two types of waves. One is supposed to be a transverse wave, another one is supposed to be a longitudinal wave. So a transverse wave actually traveling, that the disturbance of energy is disturbance is traveling perpendicular to the direction of propagation. In the case of longitudinal wave, the disturbance is traveling parallel to the direction of propagation. This is the main two tools which can make you able to understand about the seismology, that is seismic waves. Now we will discuss about the seismic waves. See, the seismic wave travels from the epicentral region, that is exactly on focus, and like your water waves, water ripples traveling in the ponds, like that it travels in all possible directions all along the surface of the earth. Okay, in this case the seismic wave can be divided into two types. One is called body wave, another one is called surface waves. The body waves, the name itself explains you what is the nature of the body wave. Body wave travel all through the body of the earth as well as on the surface of the earth, but surface wave travels only through the surface of the earth. Okay, then the body wave can be divided into two types. One is called P wave, another one is called S wave, and the surface wave is called as can be divided into two types. One is called love wave, another one is called as Rayleigh wave. Okay, the P wave, it's similar to your longitudinal wave which we have discussed earlier in our you might have studied in your earlier classes. That is, there the disturbance travel parallel to the direction of propagation, that is called P wave, and this is the one wave which travels faster than that of the any other seismic waves available in this category. That is, we have discussed earlier. Okay, that is what the nature of the P wave. That is, as I show you, this is a simplified diagram of the P wave. There you can see that compressions and rarefactions alternatively arranged. That is what the case of the P wave. As I told you, the P wave travels faster than that of the any other wave, and the P wave can be otherwise called as a compressional waves also, because there is having the both compression rarefaction is there. So because of the compression rarefaction, it pulls the rock and pulls the rock. The push-pull action is experienced by the rocks when the P wave travels through the earth. Okay, this P wave is otherwise called as plane, basically depends upon the plane wave modulus. The nature of the plane wave is, the plane wave modulus is nothing but the ratio between the axial stress and axial strain. That is, it tells you the elastic nature of the rocks, which is basically decides the nature of the P wave, and the velocity of the P wave can be decided by Vp is equal to alpha, which is equal to root of lambda by 2 mu by rho. That the lambda is nothing but Lame's constant and mu is nothing but a shear modulus and rho is nothing but a density. This another one alternate formula is there, that is 4 by 3 k plus mu by rho. There the 4 k is supposed to be a bulk modulus and mu is supposed to be a shear modulus and rho is supposed to be a density. Okay, then this is supposed to be a S wave. As I told you, it is similar to the transverse wave. The S wave travels, the disturbance travels perpendicular to the direction of propagation. See, this is the basic reason behind the P wave, and the P wave travels faster than that of the S wave. Since the disturbance travels parallel to the direction, P wave can able to travel faster than that of the S wave. S wave is a little bit slower. In fact, the S wave is slower, around 1.568 times slower than that of the P wave. And here in the P wave is, as I told you, P wave can travel as the P wave actually, since it is travels slower than that of that, and another one is the disturbance is tangential to the direction of propagation. S wave cannot travel through the liquid medium, but P wave can travel through the liquid medium. That is the major reason that P wave travels slower than that of the S wave. The velocity of the P wave is decided by mu by rho. Here in mathematically you can understand, in the case of P wave it is root of k plus mu by rho. So numerator there is extra one variable is there, but in this case the one variable is less. That is why S wave travels slower than this is mathematical expression. But actual thing is, since the P wave travels perpendicular to the parallel to the direction of propagation, and here the S wave travels perpendicular to the direction of propagation, S wave always slower than that of the this one. The S wave, which one can be vertical, another one is a horizontal component of the S wave, is shown here in the graphical manner. And another one is called surface wave. This is much slower waves but longer waves than that of the P wave and S wave. But these two waves are reason for the devastation of the most of the devastating nature of the earthquakes. The surface wave, as the name implies, it is only traveling along the surface of the earth. These surface waves are more in the case of shallow waves than that of any other earthquakes available. These things. One of the type of the earthquake is called as wave is seismic wave is called as love wave, which is traveling similar to the S wave only. But what is the difference between the S wave and the P wave is S wave does not varies with the depth, but P wave you can see that it varies with the depth. The amplitude of the wave varies with the depth. The depth increases, the amplitude of the love wave decreases. This is the difference between the S wave and love wave. That is why it's called as surface waves. And another one more thing is called as Rayleigh wave. This is the most reason or most of the devastation is caused by this type of Rayleigh waves. These waves are having a rolling motion, ups and down rolling motion, which makes the buildings and other things get collapsed due to the difference in the inertia nature. So Rayleigh wave is the most devastating nature. It is like a oceanic wave motion. It goes the circular motion or elliptical motion. Here I show you the things. If you imagine this molecule goes up and down, up and down, up and down like this, and causing the devastation for the most of the earthquakes. Okay, the Rayleigh wave is actually found by Stuart Lord Rayleigh in 1885, and it is as I showed you, most of the shaking due to this earthquake alone. Okay, and as I told you, these wave earthquakes are very less in terms of depth, so that most of the shallow earthquakes are having these surface waves. Deep seated earthquakes will not have these. That is why deep seated earthquake is not creating much devastation comparing with the shallow earthquake. This is the comparison chart which we have shown for your benefit, how this all type of 4 seismic waves travels in different manner. For that there is a parallel analogy is given for your benefit. Thank you. And also we wish to show you one more animation of this P wave and S wave for your benefit, which we can make you to understand the subject much more effectively. So now you can see here you can see the P wave travels along the direction, disturbance travels along the direction of propagation. That is what the nature of the P wave. So you can able to see that how the compression rarefaction travels along the surface, and which making the P wave to create the compression rarefaction through the rocks. That see, now you can see the love wave travel. It is only with the surface. You can see that amplitude get decreases when the depth increases. So this is the major difference between the love wave and S wave. Other than that, the love wave and S wave is almost similar. Only the thing is the love wave amplitude varies with the depth. This is the type of the P wave. Here can you see that particle get compressed and elongated when the P wave travel through the rock medium. That is the nature of the P wave. And this is the Rayleigh wave. You can see that this particle goes having a circular motion or elliptical motion. You can see that elliptical motion is created by the Rayleigh wave. This is what the nature of the Rayleigh wave. Again you can see the particle goes in a elliptical order. And this is surface wave. Here you can see that amplitude is not varying with the depth. It's same throughout the depth. This is what the difference between the S wave and the Rayleigh wave. Sorry, love wave. Now you can, I think students can able to understand about the basics of the seismic waves. Thank you. We will meet in the next class.